Hi everyone, good evening. This is Shefali Singla, and in this session we will be discussing one of the major application of divide and conquer, that is quicksort. So as we discussed in the previous session, there are many sorting techniques. Obviously, सबका काम एक ही है to sort the given set of elements. So all these sorting techniques are categorized into two categories. One is non-comparison based sorting techniques and comparison based sorting techniques. तो आज वाले सेशन में जो हम सॉर्टिंग टेक्निक डिस्कस कर रहे हैं, अगेन दिस इज वन ऑफ द कंपैरिजन बेस्ड सॉर्टिंग टेक्निक एंड इट्स एन एप्लीकेशन ऑफ डिवाइड एंड कॉन्कर. तो हमारे पास एल्गोरिथम डिजाइनिंग टेक्निक्स हैं लाइक डिवाइड एंड कॉन्कर, ग्रीडी टेक्निक, डायनामिक प्रोग्रामिंग. सो क्विकसॉर्ट इज एन एप्लीकेशन ऑफ डिवाइड एंड कॉन्कर. ये छोटे छोटे पॉइंट्स हैं जो आप ध्यान में रख सकते हो. कई बार क्वेश्चन में मैच द फॉलोइंग करके दे देते हैं एंड यू हैव टू आइडेंटिफाई कि कौन सी एप्लीकेशन कौन सी एल्गोरिथम डिजाइनिंग टेक्निक के अंडर आती है. तो दिस इज एन एप्लीकेशन ऑफ डिवाइड एंड कॉन्कर. अब हमने एक इससे पहले जो सॉर्टिंग टेक्निक डिस्कस की थी, दैट वाज द मर्ज सॉर्ट. सो दैट वाज आल्सो द एप्लीकेशन ऑफ डिवाइड एंड कॉन्कर. तो इन दोनों में डिफरेंस क्या है? In the merge sort, we were dividing the large problem into two parts on the basis of the mid. See, divide and conquer में हमारे पास मेजरली तीन स्टेप्स होते हैं. सबसे पहले हम बड़ी प्रॉब्लम को, लार्ज प्रॉब्लम को डिवाइड करते हैं छोटे छोटे पार्ट्स में एंड देन वी आर फाइंडिंग द सॉल्यूशंस ऑफ दो सब प्रॉब्लम्स. प्रॉब्लम इज डिवाइडेड इनटू द सब प्रॉब्लम्स, फिर हमने सॉल्यूशन फाइंड किया सब प्रॉब्लम का, बट गोल है पूरी full fledged problem का solution provide करना. So that means we need to combine those sub problems. So what I'm saying is, if this is the problem with n elements, we are dividing this problem into sub parts. Let me call this as n1 and this as n2. कितने भी sub parts हो सकते हैं? Let's take it up to nk. मैं थोड़ा सा ओवरव्यू दे रही हूँ what we had covered in divide and conquer. So these are the sub problems. So now what we'll be doing is we'll be finding the solutions of these sub problems. इन sub problems का solution find कर लेंगे. Once the solution of the sub problems is available, then we need to combine it. So that is the third step. So in the merge sort, problem was divided on the basis of the mid. बट क्विक सॉर्ट के केस में प्रॉब्लम को हम डिवाइड करते हैं ऑन द बेसिस ऑफ द पाइवेट एलिमेंट. नाउ क्वेश्चन अराइजेस इज व्हाट इज अ पाइवेट एलिमेंट. दैट इज द मेन क्रक्स ऑफ दिस एप्लीकेशन. पाइवेट एलिमेंट होते हैं, किसी भी एलिमेंट को आप पाइवेट एलिमेंट ले सकते हो. इट कैन बी द फर्स्ट एलिमेंट ऑफ द अनसॉर्टेड एरे or the given set of elements. It can be the last element. Randomly you can pick any element. So goal is to keep this element on its correct position, that is the pivot element. किसी भी एलिमेंट को हम पाइवेट तब बोलते हैं जब वो सॉर्टेड ऑर्डर में अपनी करेक्ट पोजीशन पे. करेक्ट पोजीशन का मतलब क्या है? इफ x इज अ पाइवेट एलिमेंट, इफ आई एम कॉलिंग x इज अ पाइवेट एलिमेंट, इसका मतलब जितने भी एलिमेंट्स लेफ्ट हैंड साइड पे होंगे ये सारे के सारे एलिमेंट x से स्मॉलर होंगे. All the elements on the left hand side will be smaller than x, क्योंकि if this is sorted, so definitely sorted in the ascending order, so x will be smaller than the right hand side elements. If this property satisfies for each and every element which is on the left hand side and on the right hand side, तो हम बोलेंगे x is a pivot element. Now, the idea behind the quicksort is one by one we'll pick each element and will apply this partitioning algorithm. तो इससे क्या होगा? हर एक element अपनी अपनी correct position पे जाएगा. Then obviously at the end whatever array will be having, that will be the sorted array. So quicksort is a sorting algorithm which is based on divide and conquer algorithm. हमने पहले डिस्कस किया. This is the application of divide and conquer, जो किसी एलिमेंट को पिक करता है as the pivot element, और on the basis of this pivot element, now you can see that on the basis of the pivot element, the array is divided into the subparts. So in order to divide the elements, in order to divide the problem into the sub problems, we are using here the concept of the pivot element. और pivot element की position क्या होगी? For that we will be discussing the partitioning algorithm. We'll talk about partition algorithm. Partition algorithm means where is the correct position of the pivot element. So and partitions the given array around the picked pivot. तो ये क्या करते हैं, आप किसी भी एलिमेंट को पाइवेट एलिमेंट पिक करते हो and then you are placing that element on its correct position in the sorted array. So this is going to divide, the pivot element is going to divide the given problem into the subproblems using the pivot element, and then we will be finding the solutions. Finding the solutions of the subproblems is known as conquer. So we'll conquer the subproblems recursively to get the solution of the subproblems. Now the main focus is on the partition algorithm. Let's go through the concept of partition algorithm first. So partition algorithm is saying that it is going to divide the elements. Let's consider an example. क्योंकि अगर directly मैं algorithm पे जाऊंगी, you may find it difficult. So I'm going to consider one example. Let's say that array contains the elements 17, 35, 27, 27, 55, 15, 66, 10, 7, and 9. Now what we have to do is we need to select the pivot element. So what I'm doing is I'm assuming this element as the pivot element. First element को मैं pivot element select कर रही हूँ. So in the algorithm I have taken a variable p. So let me take this as x. X is a of p. P is basically representing the first element, first index, and q is representing the ending index. So a of p is nothing but that is 17. In this array at the position p, what element is there? That is 17. That means first element is selected as the pivot element. If you see here the function, here I am taking three parameters of the function partition, where a represents the array name, p represents the starting index, and q represents the ending index. Now x is equal to a of p. We have executed this step. Now we will be executing one loop, क्योंकि हमें पूरे array में search करना है कि जो हमने pivot element select किया है whether that is on its correct position or not. तो iteratively we have to go through each and every element. तो जब हमें iteration apply करना होता है, definitely we are going to use the for loop. So here I'm taking a loop. I'm taking a loop for the variable j. Let's say this is I, j kahan se start hoga? We have to compare this element with the remaining elements. So j is starting from the second index. Now, instead of comparing 17 with the 17, koi point nahi hai, so we'll start from the second position. So j is equal to p plus 1. That means jahan se array start हो रहा है उसके next position से आप elements को compare करना शुरू करोगे. Smaller elements should be in the front part, that is on the left hand side. So we'll check whether this element is smaller than 17. क्या 35 17 से smaller है? No. If a of j is smaller than or equal to x, then only we have to execute these steps. तभी हम elements को swap करवाएंगे, otherwise we won't be making any changes. So we'll go to the next element. So this condition is false. It is going to increment the value of j. Now j is pointing here. Again check for the same thing. A of j, that is 27. 27 is less than equal to 17 because pivot element is 17. 27 is less than equal to 17. No, condition is false. So simply go to the next step. 55 is smaller than 17. No, go to the next step. 15 is smaller than 17. Yes, condition is true. So in this case, what we'll be doing is, if this condition is true, first of all, we need to increment the value of, increment the index I. इंडेक्स आई को क्यों इंक्रीमेंट किया? क्योंकि अगर आप डायरेक्टली स्वैप करवा देते तो आपका पार्टीशन एलिमेंट ही चेंज हो जाता. So we have to keep this as it is. So first of all, we'll be incrementing the value of I. So I is now pointing here. Now swap a of I and a of j. Swap क्यों करवा रहे हैं? क्योंकि जो smaller elements है, that should be in the first half. That should be on the left hand side. So now I'm swapping the elements. So we'll be getting here 15 and we are getting here 35. Swapping is done. Now follow the same process for the remaining elements. So the idea here is, if you are getting the smaller element than the pivot element, first of all increment the pointer I and then swap the elements. If the element is greater, then simply move on to the next element. Greater means it's on the second part, so usko hum right side pe rakhenge. So follow the same process. Increment, go to the next element by incrementing the iterative loop variable j. 66 is smaller than 17. No condition is false. Go to the next element. 10 is smaller than 17. Yes. So we have to follow two steps. First of all, we'll be incrementing the value of I and then increment I, and now swap a of I and a of j. I'll get here 10 and I'll get here 27. Increment J, 7 is less than 17? Yes. So if true, then follow two steps, increment the pointer I. Now swap a of I and a of j. I'll get 7 here. 7 is swapped with 55. Now update the iterative loop variable j. 9. 9 is smaller than 17? Yes. So increment I, swap a of I and a of j. So here I'll be getting 35 and here I'll be getting 9. This is done. That means now whatever position is returned by the pointer I, अब यहाँ पे जो भी pointer I position return कर रहे, that is the position of the pivot element. So this is the position, that means this is the actual correct position for the pivot element. So finally जब हमें pivot element means 17 की position मिल गई, so we'll swap a of p means the first element itself, with a of I. So I'll get 17 here and 9 here. Now if we look at the array, we are getting here 9, 15, 10, 7, 17, 66, 27, 55 and 35. So now if you check here, 17 was the pivot element. This is the pivot element. Jitne bhi elements left hand side pe, this is the left hand side. So whatever elements we have on the left hand side, all the elements are smaller than the element 17. जितने भी एलिमेंट 17 के लेफ्ट पे सारे के सारे छोटे हैं, और जितने भी एलिमेंट्स राइट हैंड साइड पे be it 66, 27, 55, 35, all the elements are greater than the pivot element. That means 17 is placed on its correct position. This was the pivot element. So basically this position was returned by the pointer variable I. तो ये I क्या return कर रहा है? Position of the pivot element. So basically pivot element is dividing the problem into two halves. Correct? So ultimately this partition algorithm is going to return I, because on the basis of this return index, we are going to divide the problem into the subproblems. So now we'll be applying the same process on the left hand side, because this is unsorted. Same process will be applying on the right hand side. This is unsorted, and ultimately we'll get all the elements in the sorted order. So this is about the partition algorithm. Before moving on to the next step, let's understand the time complexity for the partition algorithm. Can somebody do the analysis and let me know what will be the time complexity for this partition algorithm? Is partition algorithm की complexity क्या होगी? So basically you have to perform the analysis. First of all, what we did, we took the first element as the pivot element. तो क्या इसमें आप एलिमेंट्स को, सारे एलिमेंट्स को स्कैन कर रहे हो? ऑब्वियसली नॉट. सो दिस इज गोइंग टू टेक कांस्टेंट टाइम. देन we are declaring one pointer variable, that is I. So I is equal to p, that is also taking constant time. अब यहाँ पे हमने लूप शुरू किया. लूप कहाँ से कहाँ तक रन कर रही है? There is only single for loop. So loop is starting from p plus 1, that is index 2, and it is going till end. सेकेंड एलिमेंट से शुरू होकर nth एलिमेंट तक जा रहे हैं. दैट मींस दिस लूप विल बी एग्जीक्यूटिंग फॉर n-1 टाइम्स. In the worst case, this loop is executing for n minus 1 times. Even if all the elements are sorted, अगर सारे elements sorted है तब भी इसको n तक सारे elements को scan करना है. अगर elements sorted नहीं है, then also it has to go through all the elements. So the for loop will be executed for n minus 1 times. Inside the for loop, we do not have any other loop. We are simply looking for a condition. अगर ये condition true होती है, then perform these steps. So there is no iteration. That means the time complexity for this for loop is order of n. In the best case also it will be executed for n times. In the worst case also it is going to execute for n times. So this means that it is going to execute for n times. I can represent it with the theta notation. Swap. Outside the loop, we are simply swapping the elements. This will take constant time. Returning the position of the pivot element, that is also taking constant time. So in total, we can say that the time complexity of this partition algorithm is nothing but that is linear time complexity. I can write this as theta of n. I'm using the notation theta because in the worst case and in both worst case and best case in both the scenarios, it is returning linear time complexity. यहाँ तक point clear हुआ? This is a useful point when we will be writing the reconciliation for quicksort and will be analyzing, will be finding the time complexity. जितनी भी एप्लीकेशंस है डिवाइड एंड कॉन्कर की सबसे इंपॉर्टेंट है क्विक सॉर्ट. मेजॉरिटी टाइम्स द क्वेश्चंस हैव बीन आस्क्ड ऑन द बेसिस ऑफ द क्विक सॉर्ट. इतना क्लियर हुआ? If this much is clear, first of all let's do the practice on applying the partition algorithm. This is the partition algorithm. So quickly go through these questions. I want you to apply partition algorithm once on the given set of arrays. This is practice question 1, practice question 2. चलिए practice question 1 से start करते हैं. I'm assuming हम लोग basic partition algorithm discuss कर रहे हैं जहाँ पे हम first element को pivot element consider कर रहे हैं. So this is I, this is J, and P is pointing out to the first element of the array and last element of the array. Or let me write it here because it's too much close. 13, 5, 8, 3, 2, and 11. Okay. Now here this first element is P and this is the end of the array. Last element, this is I and J. हमें pivot element क्या मिला? First element is the pivot element. So pivot element is 6. That means now we'll be doing the comparisons with the element 6. Check. 10 is less than 6. Is 10 is less than 6? No. Go to the next element. 13 is less than 6? No. 5 is less than 6? Yes. So we need to increment I. हमें दो steps perform करने. Increment I, swap A of I and A of J. Over. Go to the next element. 8 is less than equal to 6? No. 3 is less than equal to 6? Yes. So if the condition is true, we have to perform two steps. First of all, increment I and then swap A of I and A of J. Follow the same process for the remaining elements. J. A of J, that is 2. 2 is less than equal to 6. Yes, condition is true. So increment I and then swap A of I and A of J. Here we'll be getting 2 and here we are getting 10. Go to the next element J. 11 is less than equal to 6. No, condition is false. So we'll terminate here. Now this I is representing the position of the pivot element. यानी कि इस position पे आपके पास element क्या आएगा 6 and this is the last element which is smaller than 6. So what we'll do is we'll swap A of P and A of I. So after swapping these elements, we'll be getting here 2 and we'll be getting here 6. That means after applying the partition algorithm, we are getting the elements as 2, 5, 3, 6. 6 was the pivot element. So all the elements on the left hand side are smaller than the opted pivot element. And on the right hand side, we have the elements 8, 13, 10, and 11. That's it. So this is nothing but this is how we apply the partition algorithm. I hope that partition algorithm is clear. If it is clear, just let me know that what will be the result after applying the partition algorithm on the given set of elements in the array. So according to this one, what will be the pivot element? Anyhow, we are selecting the first element as the pivot element. So pivot element will be 65 here. Let's write the elements here: 65, 70, 75, 80, 85, 60, 55, 50, and 45. So first element, this is P, this is Q. J will be starting from P plus 1. So this is J and I is here. Now start comparing the elements. Apply the same process on all the elements. 70 is smaller than equal to 65. No. 75 is smaller than equal to 65. No. Go to the next element. 80 is smaller than equal to 65, less than equal to 65. No. 85 smaller है pivot element से. No. Idea is smaller element has to be on left side, इसलिए हमें swap करवाना पड़ता है. 60 is smaller than 65. So if we are getting the smaller element, it has to be on the left hand side. So for that, we will be increment the value of I first. क्योंकि अगर आप इंक्रीमेंट नहीं करवाते आई को, तो आप फर्स्ट स्टेप में ही, फर्स्ट स्वैप में ही आप पिवट एलिमेंट की पोजीशन को चेंज कर देंगे, which we cannot do. So here increment the I, swap A of I and A of J. So here we'll be getting 70. Follow the same process on the remaining elements. J, 55 is less than equal to 65. Yes, condition is true. Increment the value of I and swap A of I and A of J. Now go to the next element, J. 50 is smaller than equal to, less than equal to 65. Condition is true. So increment I and swap A of I and A of J. Go to the next element, J. 45 is less than equal to 65. Yes, condition is true. I swap A of I and A of J. Loop over. आपने एक for loop use किया था. For loop exhaust हो चुकी. Now, before coming out of this, so this means that I is representing the correct position of the pivot element. So this is the correct position of the pivot element. So swap A of I and the pivot element. Here we'll be getting 65 and 45. So ultimately आपके पास result आया 45. Then we have 60, 55, 50, 65, 70, 75, 80 and 85. So you can see here the pivot element was 65. जितने भी elements left hand side पे all are smaller than 65 and all the greater elements are on the right hand side. But notice जो भी आपके पास left side है ये सारे elements smaller है इसकी guarantee है. But all these elements are sorted, we cannot say anything. This is unsorted, left side is unsorted, right side is unsorted, but definitely as per the sorted order, 65 has taken the correct position. Is the partition algorithm clear? Why you guys are so lazy today? I cannot see any comment. Now, how quicksort works? So every time what we'll be doing is we will be applying the partition algorithm. अब यहाँ पे क्या हुआ? Pivot element अपनी correct position पे पहुंच गया. Now on this left side, on this unsorted array, I'll apply the pivot element. Like I'll be selecting 45 as the pivot element. I'll select 70 as the pivot element. So again, I'll be applying the partition algorithm on both the sides, left hand side and right hand side, because left hand side और right hand side वाले elements को भी आपको sort करना है. So we'll keep on applying the partition algorithm on the left hand side and on the right hand side. कब तक लगाते रहेंगे जब तक आपके पास सारे एलिमेंट सॉर्ट नहीं हो जाते. How many times we have to apply this? Is there any fixed count? It depends on the order of the elements. Okay, that means here the quick sort is not stable. Quick sort is a stable sorting technique. That means in the worst case it's taking order of n square, and in the best case this is taking n log n time complexity. So best case or worst case में इसका behavior different है. So that is why we say that quicksort is stable sorting technique. Quicksort is adaptive sorting technique. Stable is when we are taking the same keys और आप same keys को compare करते हो, then if the order is not changing, then we are saying that it is stable. So that is adaptive. Adaptive means जिस तरीके के elements है उसके accordingly it is adjusting. So the main idea of the quicksort will be going to the algorithm, but before that, understand if you know the steps easily, you can write the reconciliation easily, you can solve the reconciliation and return the time complexity. So the key process in a quicksort is the partition function. अभी हमने partition method discuss किया because जो main point है, main process है quicksort का, it is based on the key function. The target of partitions is to, अब ये जो हम partition function use कर रहे हैं इसका goal क्या है, मैंने अभी बताया था कि हमें हर जो भी pivot element है उसको correct position पे रखना है array में. So the target of the partition is to place the pivot element. Pivot element can be any element. It can be the first element, last element, randomly any element. So any element can be chosen as the pivot element. So the goal is to place that on its correct position in the sorted array and put jitne bhi chote elements hai, put all the smaller elements to the left of the pivot. Put all the smaller elements to the left of the pivot and all the greater elements will be on the right side of the pivot. We have taken 3 examples for the same, just go through it and we'll keep on doing the same process again. We'll follow the same process. So that is recursion. Partition is done by recursively on each side of the pivot. So pivot के left hand side पे जो elements है, right hand side पे जो elements है, आपको same process apply करना है and finally we will get the sorted array. Now on the basis of this, we are writing the quicksort algorithm. So what we are doing is, when we are talking about the DAC, DAC means it is using the recursion. DAC means सब problems के ऊपर भी आपको same method को call करना है. So that means it's making a use of recursion. जब recursion आएगा तो definitely we can write the recurrence relation. So for quicksort, we will be writing the recurrence relation. And whenever we are solving any recursive problem, we have to include 2 statements. One is the termination condition, or let me write it here. Recurrence relation है या recursive program है. Recursive program को जब आप represent करते हो in the form of the function that is known as recurrence relation. So here we have to specify the termination condition. And recursive statement. So in the if part, we are determining the termination condition. Here, the termination condition for any of the sorting technique is, अगर आपके पास एक ही element है, that means that element is sorted. So in the termination condition, I'm writing if P is equal to Q, अगर starting index equal है ending index के, इसका मतलब there is only one element. So we can say that this is the condition to check if there is only one element. If there is only one element, directly we will return that element. You can write here A of P or A of Q because anyhow both are pointing to the same position. Otherwise means problem is large. Otherwise we can say that the problem is large. If the problem is large, first of all, we need to divide the problem into the subproblems. So first step is divide and conquer में first step होता है divide. So we are dividing the problem on the basis of the partition method. Partition method में हमने 3 parameters लिए थे, array name, starting index and the ending index. And this partition algorithm is returning the position of the pivot element. So basically, if you are given with the elements and the index started from P and it is ending at Q, so now P and Q, we are dividing the problem, and this is returning the position of the pivot element. Let's say this is M. ये M कहीं पे भी हो सकता है, ये कोई fix नहीं है कि ये center ही होगा, it can be anything. So if this is the position of the pivot element is on its correct position. Let's say we had the index from 1 to 100 and I got the pivot element at the position 45. This is the position of the pivot element. So on the left hand side, obviously here we'll be having the index 44, here we'll be having the index 46, 47 and so on up to 100. तो सेम प्रोसेस जब हम अप्लाई करेंगे लेफ्ट साइड पे, सो इट विल बी कंटेनिंग द इंडेक्स फ्रॉम P to 44. What is this 44? If M is represented by 45, then this is M minus 1. Similarly, 46 is M plus 1. Now, we have to make the same function call on the left side and the right side. In the first step, we have divided the problem. Now we have to make a call on the sub-problems, that is conquer. We need to find out the solution of the sub-problem. For the sub-problem, same function को call करेंगे तभी recursive statement बनेगी. So function name is quicksort, which is taking three parameters. Array name remains the same, starting index and ending index. So for this first subproblem, this is subproblem 1, this is subproblem 2. For this first subproblem, the starting index is P and the ending index is M minus 1. This is subproblem 1. And same thing goes on the right hand side. Problem starts from M plus 1, starting index is M plus 1 and ending index is Q. Conquered. Once we have conquered, we have found the solutions of the subproblem. हमें merge करने की ज़रूरत नहीं है because anyhow we are swapping the elements. So in the array itself, all the elements are on its correct position. Ultimately, will return the array. So this is the working of the quicksort. On the basis of this, we can easily write the recurrence relation. So in the recurrence relation, we have to determine the recursive statement. So here, if the function name is t and p से लेकर q तक आपके पास n elements हैं, then here we have to determine the same thing here. Anyhow, this is going to take constant time, one comparison. Mid find करने के लिए we are using the partition function. In the best case and worst case, we had calculated the time complexity for the partition function. So in order to divide the problem into the subproblems, this is taking linear time complexity. We have to make the call on the subproblem. So it depends on best case and worst case. Best case and worst case. In the best case, we can say that the problem is divided into two equal parts. Problem is divided into two equal parts, and in the worst case there might be one side might be completely empty. हो सकता है कि जो pivot element है, if the elements are already sorted, for example we have the elements 10, 20, 30, 40, something like this. Elements are already sorted in ascending order or descending order, 50, 40, 30, कुछ भी ले लो. So if I'm selecting the first element as the pivot element, so left hand side will be completely empty and the right hand side will be containing n minus 1 elements. So in case of ascending order, if the elements are in ascending order and first element is selected as the pivot element, so on the left hand side there will be 0 element, here is the pivot element, and on the right hand side there will be n minus 1 elements. Similarly, if the elements are in the descending order में अगर elements है, then all the elements will be smaller than the pivot element. So here we'll be having n minus 1 elements on the left hand side. and zero element on the right hand side. So basically this is representing the worst case behavior of the quicksort, when one side is completely empty and the other side is containing the remaining n minus 1 element. So I can write under the worst case is when one side is completely empty and other side contains the remaining n minus 1 elements. Okay, is this clear? Now, on the basis of the best case and the worst case, we can write the time complexity. So we just need to focus on these parts. Um, so we are talking about the best case and the worst case. Best case and worst case. Best case is when elements or array is unsorted, given array is unsorted, and worst case means when the given array is already sorted, when the given array is already sorted. अगर पहले से array sorted है तो उस केस में आपके पास एक साइड completely empty बचेगी. That is behaving as the worst case for the quicksort. If we write the recurrence relation, so T of n, that means original problem is containing n minus 1 elements. We are assuming that in the best case, the problem is divided into the equal parts. This is anyhow taking the constant time if the starting index is equal to the ending index. Otherwise, if it's the best case, then we are assuming that the problem gets divided into two equal parts. दो equal parts का मतलब क्या है? On one side will be having n by 2 elements and on the other side also will be having the n by 2 elements. Basically it is n by 2 minus 1, but asymptotically we can write this as n by 2. So we have to make the call on both the left hand side and the right hand side. So n by 2 elements are here, n by 2 minus 1, pivot element ko chhod do. So n by 2 minus 1 elements are on the right hand side. So I can write this as simply n by 2. Now, n by 2 elements, in order to divide the problem into the subproblem, we have used the partition function in best case and worst case, that is taking n time. This is if P is greater than Q, or you can say that if more than one element is there. So we can simplify this recurrence relation. So this comes out to be T of n is equal to Tn by 2, Tn by 2, that is 2Tn by 2 plus n. By using the Master's theorem, we can return the time complexity. So this comes out to be n log n. I'm not going to solve this recurrence relation again because already in the previous video I have discussed that how you can solve the recurrence relation. We discussed three methods और मैंने एक वीडियो लिया था जिसमें तीनों methods लेकर आपको clearly बताया था किस टाइप के recurrence relation पे कौन सा method use करना है. So this is about the best case of the quicksort. In the worst case, we are saying that one side is completely empty and the other side is containing the remaining n minus 1 element. So the recurrence relation will be, there will be no change for the termination condition if P is equal to Q. That means, or in other terms, we can say that if there is only one element, if n is equal to 1, if n is greater than 1, that means the problem is large. Let's write here. Because ultimately the goal is to check how many elements we have in the problem if n is greater than 1. So if n is greater than 1, in the worst case, we are saying that one side is completely empty. Empty means zero element. and the other side is containing remaining n minus 1 elements and partition function. So T of 0 means nothing. So simply we can ignore this part. So we can say that we get the recurrence relation as T of n is equal to, this is T n minus 1 plus n. मैंने यहाँ पे return किया है answer with the Master's theorem. You can use Master's theorem, and on the second recurrence relation which we are getting for the worst case, we cannot apply the Master's theorem because it does not satisfy the format of the Master's theorem. We'll be using here substitution method. You can easily solve this recurrence relation using the substitution method. So time complexity, आपके पास एक series बनेगी. When you'll keep on substituting the values, you'll get a series here, and this is returning order of n square. So that means the best case time complexity for quicksort is n log n, and for the worst case it is n square. Since in the different scenarios it's returning the different time complexity, so we can say that quicksort is one of the adaptive sorting technique. Quicksort is adaptive sorting technique. Make sense? So this is about the partition algorithm and the quicksort. So if we talk about the properties, so quicksort is an adaptive sorting technique. First of all, you should know the time complexity, recurrence relation, and partition function. So summary for quicksort is partition algorithm takes theta of n in best case and worst case. In both the scenarios it's taking the linear time complexity. If we talk about the recurrence relation, recursive statement, guys, I'm summarizing whatever we have discussed. In case if you have any doubt, please let me know. In worst case, they can ask a question on the basis of the recurrence relation, best case and the worst case. So here we'll be getting T of n is equal to T of n minus 1 plus n. This plus n is for the partition algorithm. T of n is equal to 2t n by 2 plus n. Next, question can be asked on the basis of the time complexity. So we have talked about the time complexity. In best case and worst case. In best case, the time complexity is n log n. Best case वाले recurrence relation को solve कर लो. So it is n log n, and in the worst case time complexity is n square. Now if we talk about the properties, so quicksort is adaptive. We have talked about this point. Quicksort के केस में हम swapping कर रहे हैं, that means no extra space is required. Quicksort is in place. क्योंकि अगर extra space चाहिए होती है, then we say that it is not in place. But here, since we are swapping the elements, that means quicksort is in place sorting technique. And if we talk about the stability sorting technique, if we talk about stability, so we can say that quicksort is not stable. By taking the example, we can prove this. So if I take stable के लिए हम क्या check करते हैं? If we have equal keys with the equal values, then we can see if their order is getting changed or not. So let me call this as A, B, and C. This is P, this is Q, I, and J. हमने क्या बोला है? If X is less than equal to A of J. अब यहाँ पे equal वाली condition true होगी, so I need to increment the value of I, swap A of I and A of J, so it will be swapped with itself. Similarly here, it will be swapped with itself. After that, at the end, we need to swap A of P, जो pivot element है उसको swap करवाते हैं A of I के साथ. So this element will be swapped, 10C and 10. Although अगर elements को आप 10-10 करके देखते हो तो you won't be able to see this change, but इसीलिए मैंने यहाँ पे subscript दिया है so that we can observe that even if the keys are same, then also the swapping is taking place. So इसीलिए हम बोल रहे हैं कि quicksort is not stable sorting technique. It is not stable sorting technique. So this is about the main crux of quicksort, and this is the summary of the quicksort. Now the example that we have taken, in that case we have taken the first element as the pivot element, but we can choose any element as the pivot element. We are always choosing the first element as the pivot element. We can choose the last element as the pivot element. Randomly you can pick any element as the pivot element, or you can pick middle element as the pivot element. So when randomly we are picking any element as the pivot element, that is known as randomized quicksort. So randomized quicksort में कोई change नहीं आता. Randomized quicksort simply means that randomly we are picking some element as the pivot element. Okay. So this is all about this session. And in the next session, we will be discussing one important concept from algorithms, that is comparison of functions. So comparison of functions के basis पे दो तरीके से question पूछा जा सकता है. By using the concept of asymptotic notations, आपको correct asymptotic notation use करनी होगी. Or the other question can be, you might be given with 4-5 functions and they'll ask you to arrange those elements, those functions in the ascending order or descending order. So ascending or descending order means, first of all, we need to identify that which function is greater or which function is smaller. So for that purpose, we are going to cover the concept of comparison of functions. So this session will be on Friday, because as you know that we are having the free classes. दो platforms पे चल रही हैं. One is on the YouTube and other is on the Testbook platform, that is Masterclass. This is on Testbook platform. But definitely for master classes, you need not to pay anything. These are free. YouTube sessions होते हैं Wednesday, Friday and Sunday. So whatever concept we have covered, on the basis of this, we will be having the practice session master class on Thursday, and then next class, master class, is on Saturday. So the idea is, in the YouTube, I'm just discussing the concepts. बाकी concept को understand करने के लिए, if some example is required, we are we are taking those examples. But in the master class, we are focusing on the practice or the questions. किस तरीके के क्वेश्चंस पूछे जा सकते हैं, जो कॉन्सेप्ट हम यूट्यूब में कवर कर रहे हैं. तो क्वेश्चंस की टाइप्स जानने के लिए ज्वाइन कीजिए मास्टर क्लास. ओके. क्लासेस का जो टाइम है, दैट इज 6:30 PM. दैट इज फिक्स्ड. देयर इज नो चेंज, ओवरलैप होगा नहीं. And those who wants to cover the whole syllabus in detail, you guys can join the super coaching batch. So currently the sale is going on for UGC NET booster crash course, because paper is approaching. Along with this, you will be getting free previous year questions books, and you will get this course at the discounted price because currently the sale is going on, that is election pay selection sale. So for this you need to use some coupon because directly आपको 4605 नहीं दिखाएगा. Instead of 15,000 you just have to pay approximately 4600. So it won't show you this price directly. For this you need to use the coupon code. So you can use the coupon code, that is Shefali S. Okay, so this is all about this session. If you guys have any doubts or any queries, feel free to write in the chat section. Otherwise, we'll end our discussion here. So property is important है. जो मैंने last slide पे लिखा था, summary slide, that is the most important slide for the whole session. I don't think there is any doubt. So this is all about this session. Thank you so much guys for joining the session. I'll see you in the next session. Tomorrow, don't forget to join the masterclass and the link is given in the description box. And if you want to get to know more about the super coaching batch or the booster batch, so description में link दिया गया है. Click on that link. You will be taken to the Testbook platform and you can see the demo videos or structure देख सकते हो. So everything is there on the dashboard. Okay. And definitely, if you like this video, click on the like button and subscribe the channel if you are new on this channel so that you get the notifications or, for the upcoming videos. Thank you so much, guys. God bless you. Bye bye.